Hello, AP Statistics. We are looking at example 3, coins. It's very exciting. So we're going to consider a coin that is flipped 3 times. So flip, flip, flip. The first thing we're going to do is list our sample space. What would this mean? Well, this means I'm going to list all of the possible outcomes. Sample space is one of those words that we talked about in our vocabulary. So the capital S here is my sample space of all possible outcomes. Well, what does that look like? Well, I can toss that coin or flip that coin 3 times, and I can land on heads 3 times, or I can land on heads, tails, then heads, or I can have heads, heads, tails, or tails, heads, heads. I can have heads, tails, 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 heads, tails, or tails, tails, heads, or I can get all 3 tails. Ms. Griggs, why are you listing all those out? Isn't getting 2 tails and 1 head the same no matter what? No, because each of those flips is independent of the other flip. You with me? Just like the dice, I have to consider each of the flips separately, so getting a head first and then a tail and then a head is not the same thing as getting heads, heads, tails. Okay, so keep that in mind. All right, so this is my sample space, and now this is the easy part. Find the probability of exactly 2 heads. So I want the probability that I'll have exactly 2 heads. Well, this occurs here and here and here, and that is all. So that is going to be 3 out of 8 total because my sample space consists of 8 outcomes. All right, find the probability of at least 1 tail. So the probability of at least 1 tail, you could also think of it this way: 1 minus the probability of no tails. Okay, so you can think about it either way. So if I look at it this way, the probability of at least 1 tail, all I have to do is add up all the times there's 1 tail, and then add up all the times there's 2, and then 3. So obviously there's only one situation where there's not at least 1 tail. So the probability of at least 1 tail is 7/8. So if you think about it in terms of this setup, 1 minus no tails, 1 minus, well, this is the only scenario where there are no tails. So 1 out of 8 gives you 7 out of 8. There you go. Okay, part D, find the probability at least 2 heads given heads on the first coin. Okay, this speaks to conditional probability, and we are not there yet, so I am going to politely skip that part of the question, and we will revisit that later on. But I wanted you to see part A, B, and C because that speaks to the basic stuff we're doing right now. All right, more things that we talked about in our vocabulary was the idea of a probability distribution. This is a table. Okay, so I'm going to make a table from the sample space of the example we just did. So if we want to count the number of heads. Okay, so I am going to make a table, and I believe I talked about the idea that X is going to be the outcome itself and the probability of X, so the probability of the outcomes. Well, if I'm talking about the number of heads, if you will look at the sample space here, I've got a situation where I've got 3 heads here. All of these situations, there are 2 heads. All of these situations, there are 1 head. I'm out of control. I know, that's a shocker. And then here, there are no heads. 0, 1, 2, and 3. That is what goes up here. These are our possible outcomes. And then the probabilities of each of those will go down here. That's what your probability distribution will look like. Well, there are 8 possible outcomes. So getting 3 heads is 1 out of 8. Getting no heads is 1 out of 8. And then getting 1 and 2, those are both 3 out of 8. And I want you to notice something. 1 plus 3 1 plus 3 plus 3 plus 1 is 8 over 8. A probability distribution always adds to 1 forever and ever. Okay? So that is what that is going to look like. Excellent.